drawing solutions. I am DN Kamau, and I'm going to take you through drawing instruments. The main topic is Introduction to Technical Drawing, Part 2. I hope you're privy to Part 1, where we talked of importance of technical drawing. So, without much ado, let us delve into it. Professional draftsmen and engineers do most of their drawing on tables, similar to those shown in Figure 1.1. We're going to see it shortly. Although the construction details may vary somewhat on different tables, in general they are made either to a standard hire or so they can be adjusted to any desired working height. A turn of a hand knob or lever also permits the top to be regulated to various angles. On some tables, the top can be moved to full easel position. Many tables have a steel cleat on each end of the top, which is designed to hold and keep a straight edge as well as to prevent warpage. So the table is the single most important instrument that you will have apart from the drawing instruments themselves. So looking at that table, you can see that there is some kind of adjustment that can be done. Most important thing on the table is that the edges must be true. The edges must be true and 90 degrees to each other. And the top of the table must be soft and level so that it does not puncture. The pencil does not puncture the paper as you draw on it. This is a portable board that you can use and can move it anywhere. The importance remains that the sides or the edges of the board must be true and the top of the board must also be flush enough to allow smooth drawing. So we have several other drawing boards that are mounted with T-squares, quite expensive, but if you can afford it, it's also worth it. It is important with all types of drawing boards that the face are perfectly flat and smooth and that they will not twist or buckle with normal use. The edges should be at right angles to one another. Wooden boards should have a firm, even grain free from knots and should be soft enough to take drawing pins or staples easily and allow their removal without difficulty. Boards with composition surfaces can have paper attached by means of spring clips or strips or drafting tape or as described later. Pencil, very important instrument. The most used piece of equipment is a pencil. Wood drawing pencils are normally constructed of cedar wood. Their leads are a mixture of compressed clay and graphite. The pencil are hexagonal in shape so that they can be easily manipulated between the fingers and so that they will not roll off the table. Wooden drawing pencils come from 17 different hardness of lead. The hard lead produce light sharp lines, while the softer leads produce thick heavier lines. The pencil should not be so short so as to be uncomfortable when holding it. Drawing pencils are made with leads of different grades of hardness. The hardness is designated on the pencil by numbers and letters. These symbols range from 7B, which is very soft, through 6B, 5B, 3B, 2B, B, HB, F, H, 2H, 3H, up to 9H, which is the hardest. Other pencils are available, such as a clutch pencil. Many draftsmen prefer the mechanical pencil because its length remains constant and it can easily be refilled with new leads. So if you can afford a clutch pencil, this would be a very ideal pencil. They come in terms of the size of the tip, which is 0.5, 0.7, and so on. They are also graded in terms of hardness and softness, HB, and so on. So the grading of the pencil, as can be seen here, we have hard, medium, and soft, and this has been explained. In our case, it would be ideal if we had 3 grades, 3H, 2H, and HB. For whatever we require to draw, it will always be between a thin light line, which is called construction line, and a thin dark line, which is called finish line. And if you have between 3H and HB, you are able to comfortably draw any line which we shall require to draw. Sharpening of the pencil. This is a skill that you need to learn, since the pencil has to be sharpened precisely to be able to give you the correct lines that are required. To produce clear sharp lines, a pencil must be sharpened correctly. 2 types of points are used for drawing: the conical point and the wedge or chisel point. See figure 2 and 5. The conical point is best for all purpose, or especially when you are using the normal pencil work. Some draftsmen prefer the wedge-shaped or the chisel-shaped point for drawing straight lines, and conical points for letterings and curved lines, line work. Experience is the best teacher, and as you continue using these 2 types of sharpness of the pencil, you will learn on which one will be best for what kind of work. Conical. Conical simply describes the cone shape of the pencil, and the pencil, the graphite height should be at least 8 as indicated in the diagram. 8 millimeters at any given time and should not go below 5 millimeters. The tip of the pencil should be 0.5 and the height of the tip 8 millimeters. Look at the two other types of sharpening or the dulling of the pencil. Too rounded means the pencil has been dulled and therefore the thickness of the lines will not be perfect. The taper is too short. This is also wearing off of the pencil such that you cannot easily control the thickness of the pencil. So the best is the one indicated correct, and you should maintain your pencil at that. So here the first one we can see here is the chisel type. The chisel type, which is preferred on the pair of compass rather than the pencil itself. Yeah, and the conical shape we can see it the last one there, and we are seeing the graphite here at 10 millimeters. That would be a little too long, but keep it at between 8 and 5 millimeters. To use a pencil properly, hold the pencil in the same manner that you would for writing. To draw a line, always pull, never push the pencil. While you are pulling, rotate the pencil away from your clockwise between your fingers so that the point is always turning. This is to keep the lead from becoming dull and one-sided. If you want to draw a finished line, a dark line, then you will hold the pencil close to the tip. And if you are drawing a construction line, a very light line, then you will hold the pencil away from the tip. If the pencil drops, it will most probably break the tip. Therefore, it is important to keep your pencils where they are not prone to dropping. To produce good lines, continual resharpening of the pencil is a must. Some draughtmen will draw only a few lines before they resharpen a point. Sharpeners, though fast, are very prone to wasting pencil tips. A sharp knife or a razor blade, if used skillfully, may produce very good results. A small piece of sandpaper can give a smooth, sharp finishing of the tip. It will also maintain a pencil which is not yet ready for resharpening. Displayed on the screen are some of the manual drafting tools for technical drawing. One is the tri-square, which is also referred to as the T-square. The second one is a protractor, protractors for measuring angles. Third one is pair of compasses. These two are pairs of compasses. These are used for drawing arcs and circles. Then we have others like scale rule for measuring scales, French curves for drawing arcs and tricky circles. Clutch pencils, we had seen those ones before. We have pencils here, and there is an eraser. There's an eraser here. So the T-square is used for drawing horizontal lines, and it is used against the board. It has a blade and it has a head. Therefore, it is used in conjunction with a table to draw horizontal lines. It can also be used in conjunction with the set squares to draw various angles, as we shall see in the next slide. Here we can see the T-square being used against the board. Notice that the head of the T-square is flush with the side of the table or the board. There should be no space either on this top side or on this lower side. The T-square head should be flushly lodged onto the side of your board every time that you draw. That is the only time that it can give you horizontal, truly horizontal lines. So you will always make sure that you press the head of the T-square against the edge of your board. And while using the T-square in conjunction with the set square, you'll also notice here that there is no space. There's no space between the T-square blade and the set square edge here. So if there is any space here, then you will not achieve the angle that you would be required to draw. For example, here now we have the set square of 45 degrees. That means one side, on this side you will draw 90 degrees, and on this other side you will be able to draw 45 degrees. If you place a 30 degrees set square, then you will be able to draw 30 degrees on one side and 90 degrees on the other side. Yeah? The same set square 30 degrees is also called it is called 30-60 degrees set square, and therefore you can also use it to draw 60 degrees. Yeah? The method of usage remains the same, that the set square should be flush to the T-square and there shouldn't be any space between the two. Here we also have the clips. The clips are used to attach the paper to the board so that the paper does not move as you draw. Because the first thing you have to do is to mount the paper in accordance to your T-square so that the horizontal line here given by the T-square is the same horizontal line here on the paper. So you make sure that your T-square aligns your paper such that it is aligned to the T-square. Then after mounting your paper, then the paper should not be moved. It is clipped so that it should not move at any point, so that you continue drawing horizontal lines. They will be parallel to each other. That means this borderline on top here is parallel to this borderline at the bottom here, and both of them have been drawn by the T-square. Yeah, this vertical line here is also parallel to this one, and they have been drawn using T-square and set square, and this line over here is what has brought this line. Yeah. So every vertical line is drawn using set square versus T-square. and every horizontal line is drawn using T-square and placed correctly on the board. So T-squares can take many forms and many lengths. The blade here can be 1 meter, can be 600 millimeters, can be 450 millimeters, and so on and so forth. You will notice that in this kind of blade, we have a working blade where the working edge is on both sides, that you can work on this edge and you can also work on the other edge. We have T-squares that are tapered, meaning that you would only be able to use one side, and that side would be called the working edge. Set squares are available in two different shapes. Or one of the set square here is named 45 degrees. This other set square is named 60 degrees. Notice the shape. We have this long side and there's an angle here. This angle is very steep and this angle is gentle. So this angle in relation to this is 30 degrees. The gentle side is 30 degrees and the steep side is 60 degrees. On this other one, you will notice that the angle here will be 45 and the angle on this side will also be 45. So this set square is called a 45 degrees set square. It measures 45 degrees and 90 degrees. This one is called 60 or 30 degrees set square. It measures 60 degrees on one side, 30 degrees on one side, and 90 degrees. So two set squares available that you need to have. There is another one that combines the two and is called the adjustable set squares. So how do we use the set squares? We use them in conjunction with the T-square in order to be able to produce 45 degrees, 60, 30, and sometimes we also use them as straight edges, and we can also combine them to produce more angles in conjunction with the T-square. This is the adjustable set square. This set square combines 45 degrees, 30 degrees, 60 degrees, and even more angles that you can be able to produce using this set square. The advantage is that you can set it to any angle so that you produce any line. The only disadvantage is you cannot use, sometimes you may need to use two set squares to slide over each other to be able to draw some lines. In this case, it will be hard for you to use two set squares. Yeah. However, you can also use it in conjunction with the T-square to represent the other set square. At first, you will find the drafting equipment difficult to use. Only time and practice will make it easier. It is most important that the student pays particular attention to the proper use of the drawing equipment and takes pain to develop good habits. It is easier to learn a habit properly the first time than to try and unlearn it. So all the instruments are important and they need to be taken care of. You know? Wash the instruments with a soft piece of cloth and soap. Wipe off all the rubber particles and wipe your instrument every time you want to use them. Place them in an area where there is no dust. Let your instruments not collect dust because that is another way of spoiling your instruments. Use the T-square. Place the T-square ruler on the drawing board. Place your left hand on the head of the T-square to support and move it into the desired position. As you can see, the T-square most of the time slides on your board and on your paper. And therefore, you should keep your T-square clean. After the T-square is positioned, remove your hand from the head and place it on the blade of the T-square, somewhere in the area of the line to be drawn as shown. As you hold it, probably with your left hand, you're holding the blade, you should pull it towards the edge. Pull the head of the T-square towards the edge of the board such that there is no space between the head of the T-square and your board. So as you pull it, notice the hand, the way it is pulling the T-square in the direction so that the head is placed flush on the board, and at the same time the fingers are holding the set square so that the set square is also placed flush with the T-square. The left-handed student may use the left edge of the board following the same procedure. Notice now the hand that is holding the blade is the right hand, and it is also trying to pull the T-square towards the board so that the head of the T-square is launched on the side of the board squarely such that there's no space between the head and the board. At the same time, the fingers are pulling the set square onto the blade of the T-square to make sure there is no space between the blade and the set square. A set square must be kept clean, otherwise it will cause dirty smudges on the paper and detract from drawing. Set squares can be washed with soap and water, but to remove stubborn graphite on the edges completely, a small amount of petrol on a cloth can be used. It is a good idea to keep a cloth at the drawing table and continually wipe the equipment as you work. A piece of cloth or tissue paper will help you remove rubber particles that bring the dirty smudges. Care to the set squares edges must be straight and true. If they are not set square, is useless. Therefore, extreme care must be taken when handling a set square. Avoid dropping it on the floor or tapping it on the drawing board. And this should apply to all the instrument, not only the set squares. Figure 1 shows how we can achieve horizontal lines using the T-square. This is just by mounting our paper correctly so that the paper is truly parallel to the T-square, and then fastening on the board so that as we draw, the paper does not move. When you draw horizontal lines, those horizontal lines will be perfectly horizontal to each other as long as the head of the T-square keeps tight on the side of the board. Figure 2 shows how we can achieve various angles using the T-square in conjunction with the set square. The first set square shows here that we can easily draw 45 degrees and 90 degrees when the T-square is held horizontally to the board and the head is flush on the side of the board. We can turn the set square to achieve various angles depending on what set square we are using. Figure 3 shows how we can achieve other parallel lines. Yeah, when the T-square is not truly horizontal. In this case, we can draw a line whose angle is not measured. Then place the T-square and T-square such that the set square is aligned to that line, and then holding the T-square in its position, you can be able to draw the other lines. So this T-square is not placed correctly, but that is not what we want to achieve in this case. We have drawn a single line here, and this line, we do not know the angle of that line. So once we draw this line, we place our T-square and set square so that this edge of the set square is aligned to this line. Yeah? And then the set square is aligned to the T-square. So then we hold our T-square in position and move the set square as we draw the other lines. We shall have drawn parallel lines. These are other ways of holding your set squares against the T-square. You'll notice that this straight line represents the T-square. So with the T-square horizontal, then we have this 45 degrees set square. You can draw 45 degrees line here and 90 degrees. This is 45 degrees on the other direction and 90 degrees. This is 45 degrees on the upper side and 45 degrees. Then here we have the 60 degrees. 60 degrees. On this side we have 60, and on this side 90. On this side 90, and on this side 60. So this is just a matter of rotating your set square to be able to stand in this direction and rotate it against 180 degrees, and it will be able to give you the 60 on the other side. So this line, as the line before, still represents the horizontal line, and here we are now using the 30 degrees set square to do the same thing that we did up here. You can see that you can draw 30 degrees on this side and 30 degrees on that side just by rotating your set square and placing it on the T-square. The same thing is happening here, and here we are combining the two set squares after placing the 45 degrees, and then you place the other one here and you'll come up with a different angle. Same thing is happening here. We can achieve other angles by using two set squares and uh, thereby having a different angle. Here, these two diagrams show how you can combine two set squares without the use of a T-square to further get other angles. This is another way that you can use the two set squares to draw parallel lines and achieve other angles. This one shows how to use the French curves. Sometimes the curves are not very regular and they are not made to some form which you're familiar with. So in that case, you look for a French curve, and a French curve will be able to give you each and every node of the curve that you need. Dirty smudges can be kept to a minimum by lifting rather than sliding the set square into position. You will notice even when you're drawing how easy it is for you to slide your set squares and all your instruments on the board rather than to lift them up. Yeah, so lifting them up will give you a cleaner and a better work. To use a rubber properly, sometimes we assume that we know how to use a rubber, but do you? Place several fingers near the area to be rubbed and hold the rubber firmly to prevent the paper from wrinkling and tearing. Rub in several directions using only enough pressure to remove the line. Like all other drafting equipment, rubber must be kept clean. If it becomes soiled, it can be rubbed clean on a piece of scratch paper. A good rubber is one which is soft and leaves no dirty smudges after rubbing. It is a good habit to wipe off all the rubber particles after erasing. It is a good habit to wipe off all the rubber particles after erasing. Use a soft, clean piece of cloth to do this. Do not leave the rubber particles hanging around as you continue to draw. This is a potential disaster, for you will keep sliding your instrument and they will collect the rubber particles and put them right back into your work. That's when you will get the dirty smudges. A ruler is possibly one of the most important pieces of drawing equipment. Rulers should only be used to measure distances, with lines being drawn using T-squares and set squares. However, most people use rulers to draw straight lines, but it must be remembered that the edge of a ruler is not guaranteed to have perfectly straight edge, unlike a good T-square or a set square. So simply do not compare a ruler to a T-square or a set square. The drafting machine is now a standard piece of equipment in most industrial drafting rooms. We shall see it later. It is an extremely useful device since it eliminates the need for separate scales, triangles, protractors, and T-square. All of these essential drawing units are attached in such a manner as to permit their instant use. Its time saving lies in the fact that many drawing operations can be combined, such as laying out horizontal and vertical lines, measuring and laying out angles. The centralized control units allow the draftsman to accomplish these operations with his left hand, leaving his right hand free. That is an image of the machine. The machine can be moved. It has this joint here, there's another joint here, and another one here. So this can help you draw vertical lines, horizontal lines, and you can turn this to at any angle so that it allows you to draw any angle, a line at any angle. This is the adjustment that will allow you to do those angle drawings, and this is to move it so that it moves like an arm. For drawing. Thus, to draw a line of predetermined length at a given angle, and the draftman, using his left hand only, simultaneously set the correct angle and swings the arm of the drafting machine until zero of either the horizontal or vertical scale is on the desired point. With his right hand, he simply draws the line of the required length without resetting the controls. Parallel or perpendicular lines can be drawn anywhere on the board. The tracing paper. Formerly, most drawings were first prepared on some kind of opaque paper and then traced on tracing paper, from which a print was developed. Today, industrial draftmen make their drawings directly on tracing paper. Tracing paper is important, especially when you want to produce many drawings. Like in the early times when we used to have photographs and the negative. So this becomes the negative, meaning that you can be able to produce many more drawings on that, and especially the blueprints, which are mostly acceptable in the building industry. To the end of our presentation, we have looked at the drawing instruments. How do we take care of them? Do not drop them down anyhowly. Place them where they are not liable to drop down. Clean them. Use a piece of cloth to wipe rubber particles, and so on. So that actually marks the end of our presentation in the use of drawing instruments. We must also emphasize on the use of proper pencil work, because we've said you must sharpen your pencil correctly, and therefore if your pencil is well sharpened, you will come up with the correct line work, the correct thickness of the line work, the correct intensity, so that dark lines will remain dark lines and the light ones will also remain light lines. Accuracy is also another thing that we have to look at. In technical drawing, it's very important to be accurate. If your line is horizontal, let it be 90 degree, I mean 100% horizontal. If it is vertical, let it be 100% vertical. Neatness, rubber particles, wipe them away using a piece of cloth. Do not use your hands, your sitting hand. Do not use any other means of blowing the rubber particles. Just use a piece of clean cloth, wipe them off your entire space, and then you can continue drawing. And if you have to use scale, let us use the correct scale at every uh, moment. So that forms the end of our presentation. Thank you for watching. Thank you for being with us. I hope you have gained something. And uh, thank you for everything.